Hello everyone. Welcome to Vedic Maths class 01. In this class, we will learn Nikhilam Sutra that is mainly used for division calculations only. Let's get started. First of all, what is Nikhilam Sutra? As I have mentioned it, it is used only for division calculations. The word Nikhilam literally means deficient. We are going to use this deficient property divisor, also known as deficiency, in solving problems. We will learn about deficiency in the next slide. Now, the basic requirements needed to use this sutra in our division calculations are: number one, divisor should always round to the power of 10. And number two, divisor should be less than that number. For example, let's take 98 as a divisor. 98 is close to 100. That's a power of 10. And 98 is less than 100. So we can use Nikhilam Sutra for problems where divisor, when rounded to nearest tens, hundreds, thousands, or so on, should always give us the power of 10. So everyone must be curious to know what is deficiency. Deficiency is the number obtained when divisor is subtracted from the power of 10 the divisor is close to. In our example, deficiency is equal to 100 minus 98. That is, the power of 10 divisor is close to minus divisor, which is equal to 2. But we should always remember an important rule in Nikhilam Sutra. That is, the number of digits of deficiency should always be equal to the number of digits of divisor. So in this case, we make our deficiency as 02 so that the number of digits of deficiency will be equal to the number of digits of our divisor. Now, there are a few basics one must know while solving few problems using Vedic math tricks. Number one, tens or nines complement. Number two, Beniculum numbers. We will learn these basics and also solve few problems related to Nikhilam Sutra in the upcoming video. Tens or nines complement of a digit.
Now, let's learn the first basic concept, that is tens or nines complement of a digit. Tens or nines complement of a digit. Tens or nines complement of a digit is obtained when 10 or 9 is subtracted from that digit. So digit minus 10 or 9. So this is an important formula. Generally, the tens or nines complement of a digit will be negative. Let's look at some examples regarding the same. Suppose if our digit is 7, the tens complement of 7 is 7 minus 10, which will be equal to minus 3. This minus 3 is generally written as 3 bar. It's written as 3 bar so that it helps you solve calculations simpler, and it's generally written as 3 bar in Vedic using when you solve problems using Vedic matrix. Now let's find out the nines complement of the same digit. So nines complement of 7. Nines complement of 7 is nothing but 7 minus 9, which is equal to minus 2. This minus 2 is written as 2 bar, as I have mentioned, and this 2 bar is used in Vedic math calculations. Now, we will use this tens or nines complement and also find out the Beniculum number form of a number. I hope you are clear with tens or nines complement. So let's move on to the next concept, that is Venniculum numbers.
Venniculum numbers.
Let's learn the second basic concept of Vedic matrix, that is Venniculum numbers. Venniculum numbers or Venniculum form of a number is obtained when the given number's higher digits, that is 6, 7, 8 or 9, are replaced by the respective tens or nines complement. So let's solve few examples so that we will learn few rules to solve a given number to its Venniculum form. Let's solve the first example. Example 1. Convert 98 to its Venniculum form. So this is the Venniculum form section. So the first rule is we're going to convert it digit by digit, and this process is going to start from rightmost digit towards the leftmost one, so in this direction. Second, first digit that's greater than 5, and it can be at units place or to the left of digit less than 5 should be replaced by its tens complement. This is the second rule. So the first digit that's greater than 5 is 8, which is at its units place. So 8 must be replaced by its tens complement. So let's solve for tens complement of 8. That is 8 minus 10, which is equal to minus 2, which is equal to 2 bar. 2 bar, yeah. So 2 bar will be the units place of the Venniculum number of 98. Now, the third rule is digit greater than or equal to 5 and to the left of digit greater than 5 must be replaced by its nines complement. So its nines complement. So a digit that's greater than or equal to 5 to the left of a digit that's greater than 5 or sometimes greater than equal to 5 must be replaced by its nines complement. So in our example, 9 is to the left of a digit that's greater than 5. So you replace 9 with its nines complement. That is 9 minus 9, which is equal to 0. So 0 will be at the tens place of the Venniculum form of 98. Now, the fourth rule is digit less than 5 to the left of digit greater than or sometimes equal to 5 must be incremented by 1. So you just do plus 1 for the digit that's less than 5 and to the left of a digit that's greater than or sometimes equal to 5. So in this case, at the hundreds place we have a 0. So you increment 0 by 1 and you get 1 at the hundreds place of the Venniculum form of 98. Now the final rule is expanded form of Venniculum numbers so obtained must be equal to the actual number. So in our example, Venniculum number, the expanded form of Venniculum number will be 1 into 100 plus 0 into 10 plus 2 bar, nothing but minus 2 into 1, which will result to 98. That is our actual number. So hence 102 bar is the Vinculum number. 102 bar is the Vinculum number of 98. So it's pretty simple, right? Let's solve another example. Vinculum number of 834765. Now, the first digit should be greater than 5. Otherwise, increment the digit by 1. So in this case, you write 5 as it is, and the next digit will be 6. You should always start it from rightmost digit towards leftmost one. Next digit is greater than 5. So you find its tens complement, that is 4 bar. 7 is to the left of a digit that's greater than 5. So you find its nines complement, that is 2 bar. And then 4 is to the left of a digit that's greater than 7, and 4 is less than 5, so incremented by 1s, that's 5. 3 is to the left of, so you write 3 as it is, because there's no rule for a digit that's to the left of a digit wherein both the digits are less than 5. Then you get 8, wherein it's to the left of a digit that's less than 5, and you write its tens complement. And in the last, you have a 0 here, which is less than 5, and it's to the left of a digit that's greater than 5. So you increment it by 1. So you get 1, 2 bar, 3, 5, 2 bar, 4 bar, 5 as the Vinculum number of 0834765. So I hope you understood how to convert a given number into its Vinculum form. So we are going to use this Vinculum number concept while solving few complicated division calculations using Nikhilam Sutra.
Few examples.
Let's solve few problems using Nikhilam Sutra. Problem 1. This is quite a simple problem. 899 divided by 98. We are going to use deficiency of divisor for solving this problem using Nikhilam Sutra. So let's calculate deficiency of 98. Deficiency, also denoted by def, of divisor, which is 98 in this case, will be equal to power of 10 close to divisor, that's 100, minus divisor, which is 98. That will be equal to 2. But there is an important condition that must be satisfied while calculating deficiency of divisor. The condition is the number of digits of deficiency should always be equal to the number of digits of divisor. So in this case, you just add a 0 in front of 2 to just satisfy the condition. Now, here comes the important part. We are supposed to divide this dividend into two parts. One is called the quotient part, denoted by Q. Another is called the remainder part, denoted by R. This division process should start from rightmost digit towards the leftmost one. The remainder part is supposed to have same number of digits as that of the divisor. So in this case, remainder part should have 2 digits. And remainder part is the first one to be calculated. So let's start dividing. 1, 2. So 99 will be included in our remainder part. Now the remaining digits will be included in the quotient part. In this case, there's only one digit, that's 8. But viewers, you should always remember an important thing. We can solve this without using Vinculum numbers if and only if the number of digits of quotient part is less than or equal to number of digits of divisor.
Now, in this case, quotient part has only one digit, so we are not going to use the Vinculum number concept in this case. So let's get started. Deficiency denoted by def, that's 0, 2. Quotient part, remainder part. Quotient part has 8, remainder part has 99. So you're supposed to multiply this deficiency with the leftmost digit and add it to subsequent digits until the last digit is being added. So in this case, the leftmost digit is 8, that's under quotient. So 0, 2 into 8, which will be equal to 16. And it's added to subsequent digits, that is the remainder, which is 99. So 1, 6, this will be added. So you'll get quotient as 8 and remainder as 115. But all of us know an important rule for division calculations, that is, remainder should never be greater than or equal to divisor. But in this case, remainder is greater than divisor. So what do? We simply do a simple division calculation to find out the ultimate remainder. So 98 divided by 115. So 98 once is 98. So you'll get 17 here. So 17 is the ultimate remainder, and quotient. Quotient will be nothing but the quotient that's obtained after solving the problem using Nikhilam Sutra plus the quotient that is obtained after doing simple division calculation. So which will be nothing but 9. So quotient and remainder are 9 and 17 respectively when 899 is divided by 98. Let's solve another problem. Problem 2. 83475 divided by 99. So 83475 divided by 99. In this case, 99 is our divisor, 83475 is our dividend. So we are supposed to calculate deficiency of divisor. So deficiency, also denoted by def, of 99 will be equal to power of 10 close to 99. That's 100 minus the divisor, which is 99, which will be equal to 1. But to satisfy a condition, you're supposed to include a 0 in front of it. Now we're going to do the same thing. We're supposed to divide this into two parts. One is called the remainder part, other is called the quotient part. So remainder part is supposed to have same number of digits as that of the quotient, as that of the divisor, and quotient part will have the remaining digits. But in this case, viewers, you must have noticed that the number of digits of quotient part is greater than the number of digits of quotient part is greater than the number of digits of remainder part or digits of divisor. So in this case, we're going to use Vinculum form of dividend as our primary dividend to solve this problem. Vinculum form of dividend as our primary dividend to solve our problem. So let's find out the Vinculum form of the dividend, that is 83475. So 83475 and its Vinculum form. Now, according to the rules that I have mentioned in my previous video, in the examples which I solved in my previous video, so the first rule is you're supposed to start digit by digit from rightmost digit to the leftmost one, and the digit that's greater than 5 should be replaced by its tens complement, and it can be at its units place or to the left of a digit that is greater than 5. So in this case, first digit is 5. So since 5 is not greater than 5, you write it as it is. 7. 7 is greater than 5. You replace it with its tens complement. 4. 4 is to the left of a digit that's greater than 5. So you increment 4 by 1. 3. 3 is to the left of a digit that's less than 5, and 3 is also less than 5. So you write 3 as it is. 8. 8 is to the left of digit that's less than 5, and 8 is greater than 5. So you replace it with its tens complement. 2 bar. That's negative 2. And next, you'll be having a 0 in front of 8. So you just increment it by 1 because 0 is to the left of a digit that's greater than 5 and 0 is less than 5. So you'll get 1. So 1, 2 bar, 3, 5, 3 bar, 5 is our Nikhilam form of 83475. Let's start our division calculation. So 1, 2 bar, 3, 3, 5, 3 bar, 5. 3, 5, 3 bar, 5. So as I've mentioned it, this will be our primary dividend, divided into two parts, remainder part and quotient part. Remainder part is supposed to have same number of digits as that of divisor. In our case, divisor is 99 and it has 2 digits. So remainder part will also have 2 digits, and you're supposed to start this process from rightmost digit towards the leftmost one. So quotient part will be having the remaining digits. Let's note down the deficiency which we have obtained. That's 0, 1. So we're going to use the same rule. Multiply the leftmost digit and add it to subsequent digits until the last digit is being added. So 0, 1 into 1 added to subsequent digits. So you get 1, 2 bar, 4, 5, 3 bar, 5. Again, 0, 1 into 2 bar to subsequent digits. So 0 minus 2. So you'll get 1, 2 bar, 4, 3, 3 bar, 5. And 0, 1 into 4 to subsequent digits. 1, 0, 1 into 4 to subsequent digits. So this will be 1, 2 bar, 4, 3, 1, 5, because 4 plus minus 3 will give you 1. Next, 0, 1 into 3 to subsequent digits. So that's 0, 3, and we have finished adding all the digits of the dividend part. So 1, 2 bar, 4, 3, 1, 8. So the remainder obtained when 83475 is divided by 98 is equal to 18. And the quotient part is 1, 2 bar, 4, 3. But this is not the proper number. It's written in its Nikhilam form. How do you get the actual number? You get the actual number by simply solving its expanded form. That is 1 into 1000 plus minus 2 into 100 plus 4 into 10 plus 3 into 1, which will be equal to 843. So our quotient and remainder obtained when 83475 is divided by 99 is quotient will be 843 and remainder will be 17. Wait, remainder is 18. Sorry. Remainder is 18. So we have solved the examples using Nikhilam Sutra, and I hope you have understood how to solve such division problems wherein the divisor is close to the power of 10 and is less than the power of 10 using Nikhilam Sutra. The only objective of using Nikhilam Sutra while solving division calculations is you don't need to get scared or you don't need to feel tensed while solving such big calculations. Like, for example, in our second problem, we took 83475 divided by 99 as our problem, as our division problem. So we don't need to get tensed or feel this problem to be quite complicated while solving it in our exams. So the main thing that helps you when you learn this sutra is it helps you get rid of the fear of problem. Sometimes students get scared of looking at big problems, complicated problems. They don't feel quite confident and often tend to get wrong results. So using this Nikhilam Sutra, I hope that they feel confident, they'll attempt the problem correctly, and they'll get good results. Hope you all have understood how to solve such division calculations wherein divisor is close to a power of 10 and is less than power of 10 using Nikhilam Sutra. Thank you.